Using functions to model relationships, example number 4. A pool is being drained so that it can be repaired. The graph shows the amount of water in the pool during the time it takes to drain it completely. Write the function that is represented by this graph. Identify the rate of change and the initial value. All right, so this time they are giving you the graph, and they want you to use the graph to write the equation. Okay, so write the function means write the equation. Let's go ahead and underline that word. Actually, underline the whole thing that says write the function. And then let's put write the equation. Okay, so looking at this graph. First, let's go with the initial value, because the initial value is very easy to see. So looking at this graph, your initial value is where the graph starts. That is the y-intercept. Remember, this is my y-axis. This is my x-axis. So where does this graph touch the y-axis? Right here. So each one of these grid lines represents 1,000. So this would be 2,000 here. This would be 4,000 here. And this would be 6,000. So that means that my initial value is 6,000. Now we need to find the rate of change. Well, finding the rate of change, which means find the slope of a graph, is nothing new. We have done this over and over again. We just need to pick 2 points and find our rise and our run. So let's pick this point right here, and let's pick that point right there. Now you could say, like this point right here is 80, and this point right here is 3,000. And you could use your y2 minus y1 over x2 minus x1. You could use that formula to find the slope. There's nothing wrong with that. But I just think it's easier, given this graph and the points fall right on the grid lines, it's easier just to find your rise and your run. So let's draw a line down. And draw a line across. Okay, so now the key word there I said was down. This slope is going down. So if it's going down, that means our slope is going to be negative. So don't count the lines. This is not -3. That would be wrong. Remember, each grid line here represents 1,000. So this would be down 1,000, down 2,000, down 3,000. So our rise is -3,000. And our run goes from 4 to 8. The run goes from 4 to 8, so that would be 4. Okay, so let's go ahead and write this information down. Let's start with our rate of change. Our rate of change, which is the slope. Our rise is -3,000. And our run is 4. If you divide those out, you get -750. Now, for this problem, what does that mean? That means that the water is being drained at 750 gallons per hour. It's draining at a rate of 750 gallons per hour. Notice I didn't say it's draining at a rate of negative. Because I'm saying the word draining, that's indicating that the number is negative. So this would be -750 gallons per hour is our rate of change. Okay, our y-intercept, our initial value. That's this number right there. So in other words, it starts with 6,000 gallons of water. Okay, we know our rate of change, we know our initial value. Now it's time to write our function, write our equation. So remember, rate of change goes in front of x, the initial value goes behind x. Slope goes in front of x, y-intercept goes behind x. Y equals mx plus b. So y equals negative 750x plus 6,000. Okay, if you have any questions on example number 4, please don't hesitate to ask. Thank you.